All right, everybody, it's Robert Cooper again for data visualization. We're going to talk about mapping. I'm going to give you an intro to mapping, and it's one of the more, I suppose, complicated things, and partially that's because there are lots of different kinds of objects that you might deal with, and there are lots of different packages that could become useful for you. So I'm going to talk briefly about these, and I'm going to go through an example. So SF will be good for what I'll explain are simple feature objects. RGDAL for reading in like ArcGIS style shapefiles, ArcMap, ArcGIS type shapefiles. Spatial is a really easy way to convert SP and SF objects to data frames. USA boundaries and USA boundaries data are good for some US map data points and historical maps. And then TMap is really good for SF and SP objects for mapping. You can also use SPplot. I did not put that in, but that's another option, SPplot. Okay, so first you need to understand when it comes to mapping the types of objects I'm going to discuss today. I'm going to skip things like rasters for now. A few object classes to be familiar with, especially, are SP, SF, and spatial data frames. And those are listed in order of complexity from greatest to least. SP objects are actually a different type of object in R than you're probably used to using. They look like lists, but they're nested lists. They have extra layers of structure. I say here that they are a kind of a list on steroids, right? There's a lot of data nested in these. And they use different subsetters. They use the @ symbol for slots as opposed to the simple $sign. Now you can use the $sign in certain situations, and you can use this bracket subsetting in some situations, but the nesting structure is based on the @ symbol as well. And that's different. It's called an S4 object, and it's got unique properties. SF, or simple, that means spatial polygon, by the way. SP object. SF is for simple feature. It is 1 degree more complex than a regular data frame because it has a column, a vector called geometry. It's actually a list type structure. It's got more than just values for longitude and latitude. It's got projection, it's got a bounding box, it's got all that kind of stuff in it. So, but what's great is that an SF object is very flexible. ggplot can work with it very easily, and it's also smart if you use like the geom SF layer in ggplot2, because the geom SF knows where to go to get all the information it needs to make the baseline plot. If it's an SF object, all the directions on how to put the lines, the polygons, or the points together in any kind of order would be inside the geometry. And all mapping data is really either points, lines, or data polygons. So that's what we're dealing with. There are a lot of packages that have data for maps. ggplot2 has its own map data. There's a maps package that has data sets, USA boundaries data. There are a lot more than I'm listing here. There's some that have some really great natural features. There are some that have really good geopolitical features. That's something that you should explore. And all that matters really is that you know how to work with the type of object that they have. Whether their data sets are probably almost always going to be in SP or SF, but some of them are actually in DataFrame format. And that makes them pretty easy to work with. I should say, that the only issue with converting sometimes the more complex SP or the SF to the data frame is that SP objects, when you use the appropriate plotting functions to plot SP objects or SF objects, they are smart in that they have the directions for the order of how to draw together the polygons or the lines. Right? In in ggplot with just a basic data frame where longitude and latitude are variables, you need additional information because GM Polygon with the data frame cannot structure the directions on how to draw the points together unless you include more information. There's another aesthetic that you need in order to be able to complete just a regular spatial data frame and actually complete the map correctly. You need what's called the group variable. Because let's say you've got 10 points in space. You need to be able to tell ggplot, tell RStudio, if it's supposed to be broken into 2 sets of 5, if there is an order to that. Because just think more conceptually, if I give you 10 points on a piece of paper and ask you to connect the dots, and I give you no instructions, there are quite a few number of ways that you can actually put those together, right? So the idea here is that when you use a spatial data frame, you're going to actually have to give it some instruction as to how to draw the points together. Okay, so spatial data objects, S4 class, very nested, very large. Again, SF, I think, is probably the best overall to use because it has features that are like the regular data frame. And it has features that are a little bit like the SP object in that the geometry part has easy to follow instructions for geom_SF, for example, or tmap or something like that to draw the lines or the polygons together. So I am going to, I've changed up the example here. So I'm actually going to go ahead and read in some data. So it's starting as a shapefile. Shapefiles will come in a folder with a series of files that you need to leave in the folder, but you only call the shapefile the .shp file. So I'm calling it sp.1, and this comes from, and you'll see this come up, so this means that it worked. And then from the SF package, which helps working with simple features, the SF, the type of object that I kind of prefer. You see sp_sf dot. This stRead function reads in the exact same file. We're working with US climate station data in this case. And it reads it in, and it immediately converts it into an SF class. So this is an option. You can also convert it after you've imported the data. It doesn't really matter. But just to prove, here's the class of sp.1 with the read OGR function from the rgdal package. And you can see that it's an SP object, which is the funky, super nested list on steroids that I was talking about. Okay, and then you have sp_sf. You can see this is SF or data frame, so this is a simple feature file. All right. Now I'm gonna show you the structure. Basically, I'm gonna print out the list structure of sp.1 so you can see how crazy it is. And it went really fast, but you see these @ symbols, and then you see the subsetting inside. Right. There's a lot. This is actually quite a small, simple one relative to some of the ones that you'll see, but it's very different the way the subsetting occurs. Okay. You can, for example, go to the @data, and you can extract what's basically the data set that's inside the SP object. Okay, so we have an ID, we have what's really the station, the state FIPS code, latitude, longitude, and then the P's, in this case, stand for precipitation, and the T's that start here stand for temperature, and there are 12 for each, one for each month. So P1, P01, and T01 are for January. And then there's a PYR for the total year. Okay. All right. And then there's always going to be what's called a B box, bounding box, and that gives you basically the smallest box encompassing all the points. And then there's a projection string, because every map has a projection, because we are taking a non-two-dimensional estimate of the Earth in some fashion, and we are projecting it onto a two-dimensional space, so we are reconfiguring it in some way. And there are certain projections that, say, the United States uses, and there are certain projections that European maps tend to use, and these kinds of things. You can these things are easy to sort of look at and sort of figure out. All right. So, like I said, you can work with an SP object. You could use tmap or spplot to map an SP object, but I'm going to tell you you should go ahead and go to SF. Let's do SF. We're going to do an example with the data that we just read in. Okay. And then I'm going to do a couple of different options where I just do some really quick mapping. I'm actually going to clear. I'm going to clear the mapping environment, the plotting environment, and then we're going to start fresh. Okay. All right. So what I'm going to do, I'm going to use, I'm actually going to start, I'm going to skip these for a second, and I'm going to start right here. So I'm working with the SPSF data up here, this one right here. The one where I read it in, I imported the data, and I immediately turned it into an SF object, a simple features object. Okay. Here's how crazily awesome SP or SF is when you use it with ggplot. Okay. So again, here's what SP underscore SF dat. Let's just print and see what it looks like. It's got all the data. It's got a bunch of information about the bounding box and the projection system. And then it's got a geometry object here at the end. Okay. Here's how cool this is. You can just take that data set. You can take that SF object with what looks like a normal data set, and then with some extra information on top, and then the weird geometry sort of list object. All right, so let's start by doing the basic map. We're going to use nothing to start except for the original SPSF DAT, which is our climate data in SF object form. So it's got the geometry and the data set, and it doesn't have the crazy nested features of the SP object. What's great here is that ggplot and GMSF are smart, and they can figure out what to do based on the geometry and the additional information alone. So you don't actually need to add any aesthetics or any of that kind of business, just to plot a basic plot. As you can see, it's clearly the United States, the contiguous United States, the continental United States, plus Alaska and Hawaii. But we don't have a map yet or anything like that. But you can see that just based on those climate station data points, in this case we're in points, not polygons or lines, that SF works pretty intelligently and follows the instructions from the geometry. So obviously, let's say I wanted to map the United States underneath. Let's do that. So I'm going to take it from the US boundaries data to start. When we use this particular library, you can use US underscore and things like states, I believe cities, and others. I don't remember, maybe counties. Yeah, counties as well. So in this case, we're going to use US states, and we just open close parentheses, and it's going to save everything as what we call state dat here. If we look at it, you can see there's the multi-polygon geometry at the end, and a bunch of data for the states. And then you can see the projection and the bounding box and all that information is at the top, just like with any other SF object. Okay, so simple feature object, we now have, this is the map data. All right, so map data. We're going to skip down. Oh, you know what? Instead, let's add, because this is what I did writing up the example, let's add an aesthetic for the temperature in June first. And so the rest of the geom_sf knows where to go to get the information about where to draw the points and how. So the only aesthetic you need to add is the one that's going to be new, where we're having the points colored by the temperature in June in this case, if you recall. P was precipitation, T was temperature, and we have months 1 through 12, so month 6 for temperature is T06. All right. We run this. It's going to look the same, except we're going to get some color in the points. And I put a minimal P in there. So you can see the variation is now plotting. That's great. And yes, let's add the map. So I have states 1 and states 2. Yeah, let's do this. But this is actually good. This is very useful because the one that says map data, so that particular line, comes from ggplot2, and that's actually a normal data frame of mapping points. So that's going to be DataFrame, not an SF object. States 2 is what I was just writing above. That is US_states for USA boundaries. That's an SF object that has geometry. Okay. So you look at class of states 2, and then you look at the class of state 1, and you can see that they're different. SF versus SF data frame. What's great is you can actually mix data frames and SF objects together. So this actually becomes very useful. In this case, I'm going to start with the states 2, which is the SF object. Okay? So we have a SF mapping data, and then we have SF data for the climate station. So we have 2 layers of simple feature data. So I'm actually going to start with the map data, just to build the United States, ggplot geom_sf. Now if I broke the code here, you can imagine what would happen. It would produce a plot of the United States, and you see the projection is kind of funky in that we've got little bits over here that belong out to what looks like the outer islands. So we're going to have to do some chord limiting, which is what happens down here, to zoom in on the contiguous United States. Now we can add another geom_sf. We just say, okay, now we're specifying that we are now in the climate station data. So this is the label for the SF object. And then all we have to add, again, is the aesthetic for the non-mapping features, the actual data and the variation in the data. So color equals the June temperature data set, the variable. Okay? So let's add that on top of this map, and we're gonna, I made some chord limits so that we could zoom in on the continental United States. Let it stretch out a little bit. So now I would continue to change some of the non-variable features, the visual features here. I would reduce the size of the borders. I want them a little thinner. I might change the color scale with, in this case, a scale color gradient N would be a really good choice. And obviously we would want some maybe longitude, latitude, and tidal, and change this TO6, those kinds of things. But you can see it's working now, right? All right, so I'm going to do one more version where we mix a data frame and a simple feature together. All right. So here I'm calling states 1, which is this map data states. This is the, if you recall, just a basic data frame. So it just has longitude and latitude, and because it's a data frame, it needs another aesthetic for grouping, because otherwise, if you're trying to create polygons and draw points together to create lines, and then lines to create polygons, you need to give it some instructions about how to draw those together. So you can see here, I start again with the mapping data. So I start with data equals states 1. I could have just said states 1 and piped in, it would have been the same. Then geom polygon, longitude, latitude, you got to make sure these obviously map these actually match your variable names. Group equals group is where we get the grouping variable for the order. So that part is all just a regular data frame stuff. The next line, we switch it up to SF, and we call a new data set, which is, I define this elsewhere also as new.2, but it's the same as the climate data. I just copied and renamed it. That should, let's see, what do I have? SPSF dep. Let's do, let's change it back to SPSF dep. Okay. And then, in this case, let's switch it up, and I did a January temperature instead. Okay. And then I made kind of a palette that matches. I just used blue and yellow. Normally I would use a hex code and do a little bit more variation on the colors. I just did this fast. Okay, let's stretch it out so we can see. And it's taking its time, changing the view. All right. So that actually looks pretty good. The blue represents cold and the yellow represents warmer. This is January. I should put that in the labels, obviously, those kinds of things. But as you can see, so the underlying map was a data frame map. And I didn't change to like a light gray. I didn't change the borders or anything. It actually kind of looks good with the darker United States in this case. But you can see how I've mixed data frame and SF and done it correctly. So when it comes to a geom SF, all you need to add for aesthetics is anything that isn't the fundamental features to be mapped. So anything that comes from the data that are variation that you want to map in some other aesthetic, like color, fill, line type, those kinds of things, whatever. If it's variation in a variable that isn't explicitly related to how to map a line, a polygon, or a point, then you don't. Then it goes in an aesthetic. If it's related to the actual mapping function, then you don't need to put anything in there. All right, I'm going to stop talking about this for now. I'll do another video that's talks a little bit more about different kinds of mapping later. Thanks.